We are enhancing the secret messages project from the YByte Python curriculum, available at www.ybyte.in. Secret messages is a very interesting project where the idea is that we take messages, for example, Python is cool. We encrypt or encode them, let's say, in a form that it's hard for us to read what's going on. Now, clearly, these messages, can be used, for example, to communicate with somebody, to maintain a secret, or even in serious applications like banking, financial transactions, or let's say in a battlefield. So, very interesting project. In the last video, we looked at how we can, generalize our even odd swap to become what is called a generalized swap, where instead of just working on groups of two, I work, let's say, in groups of 3, 4, 5, and I jumble up letters in there. Now, the next logical question is that how do I decode this? And that's what I'm going to cover in this video. In fact, turns out that decoding is actually quite similar to encoding. But before I go there, let's look at a few examples. Let's say we are working on a group of 4 and we have this situation PYTHON. Remember, in the group of 4, my indices are going from 0, 1, 2, 3. Now I am encoding this based on this key that I have provided. So basically I take, for example, the letter at position 0 to position 3, position 1, I retain it position 1, position 2, I take it to 0, and position 3, I bring it to 2 based on this key. And that's what I've illustrated here. Now think about it. If I have to decode this, basically I have to just unjumble these letters, which means that I just have to ask myself this question: where did this letter really come from? For example, say now this is letter 0 on the encoded string. I just have to ask myself, where did this come from and how do I know the answer? Well, I can look at where I find a 0 inside this string. So for example, I find a 0 on the item number 2 here, which means that the letter 2 must have come here. And all I need to do is to move this letter back to 2, and that's what I would do by saying, okay, I'll use a key of 2 here. For this was 0, this is 1. 1 came from the same location, so nothing changes here. Letter number 2 here must have come from 3 because this is 0, 1, 2, 3. So item number of 2 is 3. That's why I'm going to use say 3 in this position. And finally, I know that the last letter must have come from 0. In fact, I see that directly, and hence I must take this last letter back to 0. So the point is that if I can just somehow create a new key, then I can run my algorithm once again, and in fact the letters will get unjumbled, and that's what we see here. We'll see this a little bit more formally later, but let's just look at one more example to make this clear. Let's say we deal with groups of 5. Now again, the same logic holds. We have an encryption key, so we say, okay, it's 43102, which means the 0th letter goes to 4, first letter goes to 3, and so on and so forth. Now, while decoding, I just ask myself this question: okay, if I look at 0, for example, where did this letter come from? I'm going to find 0 inside this key, the item number of that, and that's 0, 1, 2, 3, or say index in Python. So that's why I put a 3 over here. And likewise, you'll find that if I followed this key, for example, which has been obtained by finding out the item number of 0, item number, or say index of 0, index of 1, index of 2, index of 3, index of 4 inside the encryption key. If I did this, you will find that the encryption will just unjumble itself, and I would have my clear text available to me for me to read. Which means that if somebody has to decode this, he must know the original key, and from there he must generate a new key. And that's what we look at. In fact, we already kind of alluded to this. The whole idea is that every item in the encoded message must go back to the place where it came from. In other words, I can look at, for example, the index of 0 inside this key, the index of 1 in this key, index of 2 in this key, and so on and so forth, and that will become my new key. Doing this is not hard. In code, what I will do is that I'll just define, let's say, for example, a new key. Let's say call it D key. E key was my encryption key, so I define a new key. I initialize it to all zeros. Now remember, this key also must have the same length as n, so I just initialize to all zeros. And then finally, I just element by element update this by saying, okay, look, I want to find out where was, for example, 0 in E key, where was 1 in E key, and so on and so forth. And this is done by this index operation. Let's see this working, and then we can be convinced of this, right? So I come in here, for example, here I'm using n of 6 and I'm using this as my E key. Let me generate my, let's say, D key. So I just say D key is equal to, say, 0 times 6. Now this alone, actually let me do 0 times n. So this creates a list of n elements. Now like I said, I'm just going to say for kk in range, let's say n, all I'm going to do is that I'm just going to say key, d key, say kk is equal to, I'm going to just find out e key dot dot index kk. Yeah, and with this, in fact, we can print our d key, so it'll be nice. Okay, so let's see, our E key is here. So let's just print our D key and see what's going on. So now notice it says D key is going to be 524301. And we can validate this because item number of, or say index of 0 in E key is 5. That means that the fifth element is coming to 0, and hence must move the 0th element to the fifth for decoding. And with this done, in fact, we are in a very good shape. We can now just see this decoding working. Remember, my X was meet me in the lobby at 6 p.m. I have this X encoded general, which is something which has been encoded. Now I want to decode this, so all I'll do is that I'll just call my general swap once again. General, say swap once again with X encoded message this time, but this time around I'll say N but D key, because that is my decoded key, and I get exactly what I was looking for. It decodes my message. It says meet me in the lobby at 6 p.m. Now it's very, very interesting to think, how does this jumbling first happen and how did this unjumbling happen? This also tells you that if you were to use this kind of a scheme in practice, you must not only send the message, but you must also somehow tell the key to the other person so that the other person can decode this. I hope you found this interesting. In general, if you find that this way of learning Python is interesting, is useful, it makes you think, makes you understand the real world much, much better, do look at our website because we have tons and tons of such activities. Take care. Thank you so much. Bye bye.